Hello, everyone, and welcome to a Data-Centric AI panel on practical data-centric AI and what it means. I will be your host for the panel. My name is Chad Sanderson. I am a data platform product manager at a late-stage company called Convoy, which operates out of Seattle, and I own all of our data infrastructure and machine learning infrastructure. I've got three very brilliant AI-centric folks on the platform with me today, Anupam, Fedor, and Atalia. I'm going to turn it over to them and let them introduce themselves to you now.
Hi, everyone. I am Atalia. I am the lead developer of the Data Robot Technical Market Story. And I'm a former customer-facing data scientist in the company. So I've worked with multiple customers in different industries, helped them to adopt AI in the organization and to solve complex machine learning problems.
Hello, I'm Anupam. I'm co-founder, president, and chief scientist of Truera. Truera builds products that help with testing, debugging, and monitoring of machine learning models and the associated data. I have been working in this space for over a decade now. Before starting the company 3 years ago, I spent around 15 years on the faculty at computer science at Carnegie Mellon University. Looking forward to the conversation.
Hi, everyone. My name is Fedor, and I'm glad to be here. I run machine learning and AI in Toloka, which used to be a data labeling platform only. Now is expanding its range of products towards the whole machine learning lifecycle. I'm in machine learning for the last 18 years. And before Toloka, I was launching a few AWS services as a principal scientist.
Excellent. Thank you, everybody, for the introductions. So let's go ahead and get started. Topic of the day is, of course, data-centric AI. So let's start from the top and make sure that we are all agreed on definitions. What is data-centric AI and why should teams care about that? Atalia, can we start with you?
Yeah, of course. So data-centric AI, meaning that the focus is on the data versus on the models. So most of the time that people are contributing to the AI machine lifecycle will be spent mostly on producing quality data, and then outsource the rest, use tools that are in the market, for example, like Data Robot, in order to move models into production and develop them as well.
Got it. And Anupam, why is it important that we should start thinking about data-centric AI compared to the way the world was before? What's changed?
Yeah, that's a great question. The data has always been the heart of the machine learning enterprise. So in that context, I don't think much has changed, but there are a few trends that perhaps need to change to recognize that and embody that insight into the processes of the machine learning lifecycle. So among them, one of the things I'll highlight is that historically, a lot of the time is spent on tuning machine learning models to make sure that they're highly accurate on the data that you have available. And that's, of course, a worthwhile activity, but overdoing it might mean that you overfit to the data. So one of the recognition moving forward that is starting to get some traction in industry is that in addition to spending time on tuning models, you may want to spend more time understanding where the gaps are in the data that may be a blocker to generalization, and then addressing those gaps. That means labeling data, identifying where data might be mislabeled, identifying regions where you don't have enough data, and then once models are in production, tracking, understanding and responding to data quality issues. So that's kind of the new recognition that is putting more emphasis on becoming more data-centric.
If I may add a couple of comments here, I really like this response, and I will just add that we see that there is an increase in AI across all companies. Having said that, there is a big shortage of data scientists. So we're looking to see how we can really leverage the existing employees that we have as subject matter experts in order to really focus on what is important, what can contribute to the model, what can really create a better model and leverage our existing skill set and save time as part of the model creation and production.
Excellent. I think those are all often awesome answers. So just to summarize, the previous state of the world is that there was a lot of time spent on model tuning, and that's a worthwhile endeavor, but it can lead to overfitting. And what's equally as important, or you could even argue is more important, is understanding where the gaps are in your data. And that might mean spending more time on the labeling side. It might mean spending more time on the monitoring and data quality side. And then there's sort of this macro trend where data scientists and data engineers and other ML engineers are in short supply, and that we need to ensure that the data that we have and the infrastructure that we have is best set up to support our existing teams without spiraling into massive headcount requests. All makes complete sense. Fedor, you are someone who has spent a lot of time thinking about the labeling world specifically. Are you starting to see changes in the industry and how data teams and machine learning teams are thinking about labeling? Are they starting to move more towards labeling as a first-class citizen? What's changing there?
Yeah, that's clearly quite a curious, quite curious area of development in the recent months, or even I would say years. So there's actually multiple topics teams start to realize, and one is that the large teams who have certain ML maturity, they build a model, and then they realize, it's not performing as well sometimes. And sometimes I get complaints from the customers, or I get some errors, and why is that happening? And then they realize that they have some wrong data, and then they go back and they realize that more often now, after they already deployed this, and they starting to realize they need to monitor this every day, regularly, by updating the data the model sees, by aligning the model with the data very regularly. And in order to do this, you very often need to relabel new data, because the data drifts happen, data changes, all data might not be relevant anymore. And then if you have labeled data, then for training your model, then what you need now to update it and to monitor it again, you again need labeled data. Another important topic which I see is the growth of responsible AI, right? And then one can interpret the words responsible AI in a lot of ways, but one of the ways to look at it is that the AI is made for people and have to be looked after by people. And one of the ways to look at it in connection with labeling is by saying that you maybe don't always trust the model, you sometimes trust the people. And then you start not only deploying the models, you start combining models with models answers with people answers, and then you get a human in the loop process. And this is where the teams are going as well. And that's kind of beyond the old way of, okay, bingo, I built a model and deployed it, that's it. So these are kind of the two trends I see. I see a lot which funnel and kind of direct people's minds towards data labeling more.
Got it. Very, very interesting. It seems like a common theme, which we should definitely circle back to in a little bit, is the need for monitoring, which then necessitates a greater investment in data quality, and that might take the form of better labeling as an example. And the responsible AI, I think, is another really interesting topic, and how that changes, how organizations even set up their machine learning deployment pipelines. So let's move on to another set of questions. A similar theme, though, which is that I think now we have a pretty good idea of what data-centric AI is sort of as its core. What a lot of our viewers are probably interested in is, how do things change day to day, but also more holistically, from the model-centric view of the world to the data-centric view of AI? What are some of the practical changes that people might see on a day-to-day basis, and what are some of the macro changes that teams should be thinking about when they're going through this transition? Atalia, would you mind talking to that?
Yeah, of course. So if we understood that now we need to be focused mostly on the data, it means that most of the time, as part of the process, will be dedicated on the data. If it's on data quality, if it's on wrangling, if it's on labeling, making sure that we have the right data, having enough data for our tests, etc., and really use our skill set as SMEs, and less dedicate time on building AI platforms and workloads on that regard. It also can help with going back to your business personas and really reframe the work with them and have this building process together. So now, if you are investing most of your time on the data and use some automation tools really to help you, you can really open yourself and your organization for more innovation, and that embraces more and new use cases to your organization.
Got it. I think that's an excellent answer. So basically, focus less on supporting the infrastructure. There are some great tools out there that do that for you, and instead use the unique skill set that you have, which is your subject matter expertise, to go and spend that time and that skill set on the data itself, improving the quality, building out the data, and ensuring you're solving like real business use cases.
Yeah, correct. It also can really help you with scaling, right? Because if it's really a big challenge in the data science world on moving models from pipeline to production, and then monitoring, manage all those models in production, especially in scale when you have so many models in different frameworks and infrastructures and languages. And usually those two parts of the process are being held by different components of the organization, and I'm sure my colleagues here will be very resonate with that. So you have the ability to grow from use cases perspective, but also from scaling and managing what you have currently in the pipeline, because this is really where you can unlock a hidden ROI from models that are currently in development, and you can move them into production in a seamless way.
Got it. So I think that leads into a great next set of questions. You touched on a lot of things there. The last thing you said, I think, really stood out to me, which is that one of the extremely beneficial outcomes of this transition to data-centric AI is the focus on unlocking the ROI from the models that you have. So this is a question to Anupam. And the flip side of the ROI conversation, which is, what is the cost to the business for not investing in data-centric AI? And then on the other side of that, what do businesses stand to gain? We've talked about scaling, but what else do they stand to gain? And why should any executive team make this investment, and what can they expect to get out of it?
Yeah, that's a great question, Chad. So some of the core benefits from adopting machine learning in lots of different types of use cases is that they tend to be closely connected to business KPIs. So if you think of models in credit or fraud or computer vision or NLP kind of use cases, they're often supporting some core business function. And how well the business ROI is delivered often will track quite closely how well the model is performing on new data, on data that has not been seen by the model before. So that's one dimension. The other dimension, and I'll return to a point that Fedor made in his section, is lots of these use cases also have implications for the impact on society and the world, and being responsible in the way you adopt machine learning has risen high up in the priority of many organizations, which means the business cares about it as well. So now coming back to data-centric AI, for both of these cases, in order to ensure that models are not harming society and the world, being responsible in the way machine learning is being adopted, many of the harms trace back to gaps in the data. And I'll give you some concrete examples shortly. Similarly, the performance of models, whether they'll generalize well to new data, connect back again to how well is the data curated originally when you build the model, and then how well is it being maintained and updated once you have the model in production. So now if I take these two parts somewhat separately, when you think about responsible AI, one big area within it is fairness and the harms from unfair discrimination that can creep into machine learning models and then get reinforced and amplified at massive scale. And as you examine, and this is an area that I started working in back in 2014, and have since, the community has grown quite a bit now. Many of the problems of fairness stem from gaps in data. For example, back in 2014, we did this study of the Google advertising ecosystem. We found gender bias in the way employment opportunities were being targeted to men versus women. We don't exactly know what caused it, but it is likely that it's because of disparities in the training data. In the facial recognition systems, there was an influential study out of MIT showing that the models were really good at recognizing images of Caucasian men, but didn't do so well on women and didn't do so well on people of color. And that's because in the training data, there was a representation bias or sample selection bias. The proportion of data was quite high for Caucasian men and not so high for the other groups. And machine learning empirical risk minimization is trying to optimize for the average case. And so it learned to do well in that group and not so well in the others. So performance disparity is a measure of unfairness crept in because of problems with data that a data-centric approach to AI would have addressed. There are plenty of other examples, but I'll spare you in the interest of time. But these are good examples where responsible adoption of AI is a high priority for the business, and it has implications for cost. There's cost to the business of not doing it. Sometimes it's regulatory and compliance-oriented reasons, but it's also it hurts the brand name as well, even if there aren't regulations in place. And people also want to do the right thing in many leadership organizations. On the performance side, again, if there are gaps in training data, and we were discussing a few in the earlier question, data was mislabeled data or not enough data of the right type, or lack of data in certain regions, or data quality degrading over time and not getting detected, then the implications of that on performance is huge. And so to address it, it's extremely important to have tools in place that can support data scientists and platform owners as they go about finding areas where the data needs to be improved and do so on a proactive, consistent basis.
Wow.
Back to you, Chad.
That was an excellent answer. Thank you for being so thorough. And I think you provided a very practical and meaningful and important use case of how not paying attention, or maybe I should say not being explicitly aware of the quality of the data, can lead to real world outcomes that can severely damage customers in like very negative ways. Fedor, I'm really interested from your experience, how does that line up with what Anupam said? And do you have any other examples, being so focused on the training space or on the labeling space, of similar problems that have occurred where teams maybe didn't take the data quality or the labeling as seriously as they should, and that led to bad business outcomes?
Yeah, I mean, there's plenty of those right in the world, and even our customers' experience. I mean, you can collect a lot of different interesting use cases, such as you've built one model once, and you have this data from 1 year ago, and simply put, you are spending maybe 50% more than than what you could have been spending if you have been updating your model with the more recent labeled data. That these are examples all over the place, right? There's another important case, which is very much related to what Anupam has mentioned, is where you say, let's say you have a moderation system, and it's focused on an average class, or maybe on the most common class, and it turns out your small, underrepresented class is money laundering or money transferring, which you're trying to capture. And what happens is you're not capturing it well, and you get a very high legal risk of actually being sued for not capturing those kind of messages on your platform, right? And these are very serious risks of not carefully enough examining the data you have, or not updating the data. So the model or the data accuracy not being high enough for what your business requires. There's a lot of cases like that. I also would like to say that, in general, when you look at the value machine learning brings to the businesses, it's mainly either cost savings, reputation savings, or revenue increase, and very often with the data changes, or with not high enough quality on certain sub areas of your data, you're basically losing on very often all of these business metrics.
Yeah. I mean, I think those two cases, what you said and what Anupam said put together, should present a pretty compelling reason for any executives to take this seriously. I mean, on one side of the aisle, you've sort of got real world harm, like real world damage being done to customers, but then on the other side, you also have these potentially incredibly impactful and negative business impacts, like pricing 50% worse. I think that would make hopefully that would make any executive shudder just at the thought of having of double-digit poor pricing decisions. So, given all of that, given the prevalence of the problem and its severity, why, Atalia, do you feel, or maybe you don't feel this, that machine learning teams have been so slow to adopt these principles of data-centric ML and data-centric AI? What are some of the blockers that are standing in the way that are not allowing them to address these problems as quickly as they possibly could?
That's a very good question. Sometimes I ask myself that as well. I've been in touch with customers in both stages, right? Those who are very in the stage of realizing that this is where we're going and adopting it, versus those who are still kind of trying to figure it out. I think, in my personal opinion, it's because people are used to more the traditional approach of building by yourselves, and people have some fear on trusting maybe tools that can be like black boxes for them. Like, oh, what is it really transparent? Can I really see the algorithm? Is it better performing than what I did? And having this ownership of the algorithms. So I think from that approach of really trust the platform that you can use, if it's through the documentation, if it's through the algorithm that is behind it, and also kind of adapt to their existing architecture and existing workload. So it's not either that or that. You can still coexist with what you have. You can grow further with both of them together. Especially for data scientists that really like to code things by themselves. But if they can really look on how it can really help them with, kind of rid of I'm calling it like the boring calculation work, documentations and a simple regression model, etc., and really be focused more on the sophisticated and challenges problem that me as a data scientist can bring to the table versus spending my time on those manual work. That can be super helpful. And I always suggest on starting with one experiment that you can test and potentially to choose something that you already did. So you will have something to compare. If it's on the time, if it's on the effort, if it's on the scale. So you will be amazed with, oh, maybe I can even get better accuracy. Maybe I can get it in a faster way. And I solve myself a lot of pain in the process. And actually, it's not a bad approach.
Yeah, and maybe, Chad, if I can add a little bit to that, I think Atalia made one observation that I wanted to plus one, which is there is a segment of users who are making the shift already. And then there is a segment that is starting to think about it. That is very consistent with how technology adoption goes, right? So if you go back a few years, there was a similar kind of state of the market when it comes to training of machine learning models and deployment of machine learning models. And now in those two areas, there has been a lot more commodification, right? Training of models and deployment of models has gotten a lot more commodified. The next stage, and that's getting the basic plumbing in place, the data infrastructure from a while ago, and now these two pillars, if you will, of ML infra around training and deployment. What's the next big thing that's coming? The next big thing in my mind is ensuring that we can actually ensure that the quality of the machine learning models that you're moving into production and keeping there are of a high quality, that they will deliver on the business KPIs, and in the certain kinds of use cases where responsible AI is critical, that you have the controls in place to ensure that the models will deliver on the business KPIs and also be responsible from a societal standpoint. And in that context, adoption of this kind of data-centric view is critical, and it's starting to happen. But I would add that awareness is part of it, right? And Atalia didn't quite use exactly those words, but she was kind of hinting at it as well, that part of it is ensuring that people have the awareness of what kind of tools are available and what those tools deliver. And from our previous conversation so far, that has risen up, right? So if you think about the life cycle of machine learning, having good tools that help with labeling and ensuring data quality during model development, and then ensuring that that is also supported once models are in production. So tools for testing, for debugging, for monitoring, coupled with focusing on the areas of the data which need augmentation, which need adjustments and relabeling, making that all part of the machine learning pipelines. That's where we are headed now. And the awareness is a big part of it that we are starting to get more of, but obviously these things take some time. The one other key takeaway I'll leave it to, and I'm curious to hear Fedor's thoughts on this as well, is and this hasn't been discussed as much, but in my view, richer data-centric AI comes not just from looking at the data in isolation, but from looking at how the model views the data. And just to make it a bit more concrete, if a model is consistently making errors in a region of the data, then that helps you focus your attention, that this is a region in the data that the model is highlighting it's not doing so well on, and it needs attention. And the attention can come in different forms. It could come through relabeling, and to Fedor's point from earlier. But in some cases, it might come from taking a step back and readjusting the model in specific ways. And previously, I've given you a few examples. I wanted to just bring up one other example, which is the Zillow example from last year that I'm sure many of you and our viewers are familiar with. Zillow was using machine learning to price houses, buy them, and then flip them around and make a profit. But they ended up losing close to $500 million. And one of the big reasons for that is the housing market cooled and the models did not pick up on it and continued to price the houses higher. And this is a classic example of where the data that was used to train the model did not look much like the data to which the model was being applied. And that was not caught. The models were not readjusted. And it's a perfect example of how significant the impact can be on business KPIs if this is not part of the pipelines that we start adopting at scale across the board. Thank you.
Yeah, thank you, Anupam. This is a very interesting question to discuss. I'd like to chime in as well. First of all, I guess I wanted to it feels very natural that now the machine learning world has come to this notion of the data-centric AI, right? Is if you think about the developing any machine learning model, first, you don't have anything, you don't have ML, you basically classify the data yourself, and then you realize you cannot do this, so you start scaling up. And what are you thinking about when you start scaling up? You read somewhere about this machine learning magical thing, which like it helps scale up your data process. So then bingo, you built a model and you're done, right? Like you built a model, maybe you deployed it, and now sometimes it breaks, and you start making it more stable. And now, okay, you have a good stable infrastructure, you have a good average performance on the validation set. You're kind of done, right? And then you're thinking, well, I'm all right. I mean, my average performance is okay. My service is stable. But now imagine that this works, and then you start thinking, am I really done? And then you start thinking more about the edge cases, about the kind of the variance of your predictions, right? Like where the edge, the rare classes, or how far your predictions go up and down, the anomalies, right? And this is where you start thinking, oh, well, how do I deal with those? And then you start not looking at the models. Maybe you try waiting here or waiting there, but actually, when you look at with a data-centric view, you start fixing these problems. And actually like making your service responsible, stable, and up to date. But this only happens after you've actually built the first model and made it stable. And to Anupam's point is another thing you realize is you cannot trust the model always. Sometimes it makes stupid mistakes, or sometimes it makes things which you don't want to. Like it damages your company's reputation, or it's just not reasonable. And then you realize that the AI is not there to replace humans. The AI is there to help humans, right? The AI is there to, take the most burdensome, tiresome load of maybe simple questions, right? And then collaborate with humans to provide the final answer, right? And then you start thinking about, well, how do I combine these ML with these models with humans? And you come to the question of uncertainty of the models, and you realize, oh, okay, well, my model has to be maybe not certain, and then is my really the measure of certainty of the model, the confidence of the model I'm using, is this good enough, or is this not actually good enough? Does the model know that it doesn't know? It's a very big problem still with large neural networks. They are very often overconfident. Right? And so people start realizing that this like combination of human and machine based decisions is where they want to go. And they start thinking, how do they go about this, right? How do they make decisions? So that's certainly a trend I see.
Wow. So many super interesting answers. I have a ton of notes here, and I feel like just focusing on this question alone would probably take us to the end of the hour. But there were a bunch of things that I think you all said, which were really thought-provoking. From Atalia, basically starting off and saying that one of the big issues is actually trust. The trust of data science teams towards potential platforms that automate and manage a lot of the hard, crufty work that ends up consuming a lot of the time that the data scientists would be spending thinking about data, and that lack of trust actually prevents them from automating a lot of this sort of menial, or what we might think of as menial work or generic work, and in some ways is like distracting them from the true valuable work, which is focusing on the data. And then Anupam, I really liked what you were saying around quality, that this is a sort of a typical path in any form of software development. Like you're starting off thinking about deployment and making that process possible and automated, and then quality is usually is a relatively fast follow. And then one of the issues, sort of even outside the scope of not necessarily trusting some of the systems that are now focusing on quality, is that people are just not really aware of them. And then Fedor, some of the great things that you said, which I really want to get into, is this idea that when you're not thinking about the data, it's sort of like every problem looks like a nail, right? Like we only have hammers. And when we're only focusing on models, then we try to solve those problems with the hammer that we have, when in reality, the actual solution to the problem is to focus upstream. So many things I want to dive into there that are interesting, but I do want to start with the last one, which I think is going to be very relevant and pertinent to everyone listening, which is this idea of ownership. Most or a significant number of machine learning teams are sitting on data sets that are quite downstream of the data that is actually flowing into them. And what we're now saying, I think, is that this data is actually incredibly meaningful, and people should spend a lot more time thinking about it. How do all of you, and maybe Fedor, I can even start with you since you talked about it last, but how do you think about having this, like, well, first of all, do you think there is a gap in ownership where you've got sort of data producers that are maybe generating data that the consumers or the models are not even aware of? The producers have no idea that this model is being consumed for that purpose. Does that gap exist? It is certainly something I've experienced in my career. And if it does, how do you start to bridge that gap and have producers think about their data as, you know, a first class entity that this model needs to consume?
You know, I would say that to my experience, there are multiple different teams and organizations, and some basically own their data. So I don't think there is much of a gap between the data producers and the teams who consume it, mainly because you are the team who produce it, and then or maybe you are the team who collects it from your own website, and then that means you basically kind of produce it by writing the right logs. And then there are certainly some businesses where there's data which is being produced and the data which is being consumed, or the models which are being built kind of separated from each other. And I think that's, to me, I think that is that kind of shows itself maybe in the pre-built models market slightly. So where you have, maybe the companies to say, well, we have some pre-built models for you. And of course, these models are built on a different data that you have. And as a result, there is like a gap between the data which you have in your business and the model which you're using for your business. And that is, of course, comes usually to the bad accuracy situations or the situations where the model is just not very suitable. Another one is, let's say that there is also certain disparity I see between data production teams and machine learning teams, and then there's a question of responsibility of who is really responsible for the result of your model, right? You have a model which works well for an English American accent, but don't have a model which works well for an Irish accent of English or any other accent. And is this the data team or is this machine learning team? And they certainly have to work towards the same goal in the organization and kind of share the responsibility for the final outcome.
Got it. Makes total sense. So the next thing I'd love to talk about, still sort of pulling from that previous thread, is monitoring and quality. Anupam, you've talked a lot about that, and I would love to know more from your perspective. If you're a team that is just beginning to think about making the move towards data-centric AI, how should they think about monitoring? Like, what is important to monitor, and what are the elements of quality that are necessary for this very strong data-centric AI foundation?
Thanks, Chad. That is indeed a great question. And I was hoping to give you two answers. One is a meta answer, which also ties back to your previous question to Fedor, and then a more detailed answer. On the meta answer, what I would say is when we are monitoring data for quality, it's important, of course, to monitor the data in isolation, looking for standard quality metrics around are the missing values suddenly going up a lot? Is there a big drift in the data features? Which features are they, and so on? But equally, if not even more important, is examining the quality of the data through the lens of the model. And by that, I mean identifying issues with the data which are impacting the model's performance, or the model's impact on socially relevant metrics related to fairness and so on. So this view of monitoring is important, and that's kind of my key takeaway from this entire panel, that as you are thinking about data-centric AI, the most important meta point I want to leave you with is don't think of it as like a dichotomy between data-centric AI and model-centric AI. But in fact, richer data-centric AI comes from examining the data in isolation, but also examining the data through the lens of the model. Now, to give you some concrete examples of this paradigm, I wanted to give a couple of examples. So one example, and this is from the early days of the pandemic, when we were seeing a lot of drift in behavior of models across lots of verticals: marketing models, pricing models, fraud models, credit models. There were big shifts in consumer behavior, which was impacting the data that was flowing into these models, but was also impacting the model's outputs or the score distributions. So one kind of example is this, an example in like credit transaction monitoring where there was a sudden increase in risk scores for transactions in a segment of the population. And then the question was, what is causing it? And there were lots of examples of features that were drifting. So if you were to just look at the data in isolation, it's hard to answer the question of which of all these data drifts is actually causing the model score drift. But a more powerful analysis that can trace back, or consequential data drift, which traces back and says, well, it's because of this particular feature or set of features, that's what's impacting the model's behavior. In this case, it was related to airline spending. So what had happened was that because a lot of the users were, customers were frequent flyers, historically, sudden drop in airline spending was a good indicator of risk because people may have lost their jobs. But when the pandemic started, lots of people stopped flying because they were concerned about their health and safety. But the model had not been retuned to this new reality. And so it was flagging all these transactions as high risk because of the shift in the behavior in airline spending. But if you were to just measure data drift in isolation, then this particular feature was not drifting as much as many other features. So being able to focus your attention on the data that really impacts the model's behavior, that's super powerful. And that's where data-centric AI needs to kind of go with inputs from what's possible with a more model-centric view.
Excellent. I really like this idea that the data which powers machine learning models can't just be viewed in isolation, but actually has to be viewed within the context of the business and the world. And that requires human beings to, like, at minimal sort of understand how these changes to the model's behavior or how changes to the real world data are affecting the model's behavior. I think that's a really great point. So to shift gears a little bit, I would love to talk for the rest of the time really about what teams can do to achieve this really excellent vision of data-centric AI that we have been discussing here today. So, Atalia, I'd love to start with you and ask you the question: when you have, number one, have you seen teams that are successful with this data-centric AI approach, or are we still sort of in a learning process and we're figuring out how to do this right together? And then, as a second part to that question, is there any advice that you can give teams that understand making the move to data-centric AI is inevitable, and what can they do to help themselves and the business expedite that transition?
Sure, and I think we kind of we touched on some of those points earlier when we said that there are like two parts of organizations that either somewhere in the middle of the progress, they already identified that this is a project they will be benefit from, and the other part that is still like at the beginning, if it's been pending on trust and awareness, as we've discussed earlier. And I think, as I mentioned previously, having maybe a waterfall approach where you can choose one experiment to test and compare it to something that you already have in place. This is something that they can be super surprised with knowing without like doing a massive change of everything, just one experiment, and really stay close to the business. Many times, data scientists, they like to build, but not necessarily things that are matter for the business. So I would always encourage people to really stay close to their business personas and really understand what the business needs in order to develop something that will provide a good outcome from the business, especially when it's very difficult how to transform a very complex problem into a business manner and reduce the gap and create more trust between the technical persona to the business persona. So once you have this experiment, you did it well, you created great impact in your organization, everyone is fascinated about it, and they will look to try even more experiments going forward.
Got it. And sort of on that note, what to you makes a good experiment, and what makes a good experiment specifically in the context of transitioning to this new data-centric world? Like, what are some of the qualities that you might recommend an organization could look for when deciding what to experiment on?
So it really depends on the KPI that the business is care about, and we can find a lot of similarities. First of all, if it's evaluating the model, is looking for the model accuracy, right? So depends on what you develop, look for the accuracy of the model, and then on the KPIs that related to the business, if it's on the time saving, the cost saving, labor saving through the process, in really a way to identify. Was that a good experiment? Again, something that you already did, so you have the metrics for both, and you can compare the two.
Got it. So really the best form of experiment is to find something where there's some metric that very clearly impacts the business, something where there could be an obvious potential benefit for investing in the quality of the data, and then ensuring that both versions of the model, sort of the data-centric version and the not so data-centric version, are measured according to the same parameters and judged fairly. And I imagine the idea is to say, look at this X improvement that we got to the business metric that we care about. Now it starts to make sense to begin rolling out this process across, other features, other models, and other meaningful use cases.
Correct. And maybe another point to mention, based on the things that Anupam shared earlier, the journey doesn't stop in the model development side, right? Once you put the model in production, they were talking here on something we call continuous AI. So when you feed your model with the recent data, to see what will be the predictions, how accuracy and data drift is the model degrading over time. So those things that it's more difficult to measure from an experiment because you need time for it, right? But it's something still to consider and put in your radar to check, as it's more difficult to track those measurements manually over time.
Makes total sense. Anupam or Fedor, anything you wanted to add to what might a business want to, how might a company want to start going down the path of data-centric AI?
Yeah, sure. I think the three pillars here is related to what Atalia just covered. One is having a clear sense of the business value and how to assess it. Two is education and training. And three is adopting tools. And then it does require a bit of a commitment to assess this over a period of time, because some of the value you'll see potentially upfront during model development. But like we discussed, now we have discussed several examples of when the challenges, because during model development, you might be able to improve the accuracy of the model, but that's one dimension. We have to look at also assessments of drift and robustness and so on. If there's a rich set of criteria that predict generalizability in the future, as opposed to just during development on the more limited data set. And then once you are in production, you'll have a better way. Over time, you'll be able to better assess the impact of having these kinds of tools in place to improve the business KPIs and also the responsible AI dimensions in the set of use cases where that's relevant. So just reinforcing a bit of what Atalia highlighted. Thanks.
Yeah, let me chime in. Chad, you're muted.
Oh, sorry. I was just going to ask you if you wanted to chime in. Go ahead.
Yeah, thank you. Thank you. This is also a very, very interesting topic. To me, I like answering the questions. The questions like, "Hey, what do teams do?" For myself, I try to find certain kind of phrases which are catchy and I can remember easily, and I'd say probably two phrases which are relevant to this topic, which I'd kind of pass along for the teams who want to try to be more data-centric. And one of them is very much related to what Atalia said. And I'd say basically, you're not done with a version of the model when you deployed it. That's it. Like you always have to remember this phrase that you deployed the model, you're not done with that version of the model. You're not done, come back to the next version of the model. You don't. You start thinking, okay, well, I deployed it. Can I do something now? And then when you start asking yourself this question, then you start finding answers. Okay. Oh, well, turns out I can monitor it, or I can, like regularly check certain parts of the performance. And another one, kind of hint, I'd say before the model development, I'd formulate it as, what are the edge cases of my data, right? Okay, you have a model on average, it's good. You have a data set where your loss is decreasing, and you found that you haven't overfit. So great. But then when you start asking yourself, what are the edge cases? Like, I have my data set. Is there any corners of my data which maybe I haven't covered well? And then you start, venturing into all sorts of things: anomalies, biases, rare classes, everything. And so I'd ask these two questions, and start finding answers with data to them.
Excellent. Well, we are almost at time. Anupam, Atalia, and Fedor, thank you so much for joining us. We're going to have one more question before we end this panel. This will be our lightning round. So in roughly 30 seconds or less, if you could give us one thing that you want the audience to take away from either this conversation or from the importance of data-centric AI in general, let's go around and quickly say that one thing that we want anybody listening can bring back to their boss or bring back to another executive or even the CEO on why a data-centric AI investment is meaningful. Atalia, can we start with you?
Sure. So think outside of the box. Look for places to grow and scale. You will be happy to see better success if it's with your business, and as well with yourself, with better job satisfaction rate.
Excellent. Anupam?
That's what you need to improve the quality and your business and responsible AI KPIs throughout the life cycle of machine learning. And in fact, richer data-centric AI will come not just from examining the data in isolation, but also from looking at it through the lens of the models.
Excellent. And finally, Fedor, take us home.
All right. Well, I'd say that don't think about the models or the data as two sequential entities. Think about them as a synergy, and think about the models with humans as a synergy, and think about your systems and design your systems in a way that finds collaboration between the data decision makers, models, labelers, and all the other actors. And when we think about this as a complex system, this is where you realize that synergy brings everything forward further than individual components.
Fantastic. All right. Well, I hope everyone has enjoyed the panel. I certainly did. I learned a lot. It was great hearing all these very diverse perspectives. Please remember to stay tuned for the rest of the summit. And thank you for watching and participating.